Hello, my friends. This is the kind of plane crash that nobody would want to be in. It's quite a story. It's a pretty horrific story and oh, so avoidable. It's an accident. I don't know if the word still fits for this kind of event because an accident is supposed to be something unpredictable, unavoidable. Whereas here we're really dealing with an airline, a pilot, staff, heading straight for disaster without ever having the idea to stop it, even though it was possible. Look, it's 2024, and I'm talking about it today because the final report has come out. When I talked about it in 2024, it was still just news. So, what happened? We have an ATR type aircraft. It's an ATR, it's a French Italian aircraft, a propeller plane, twin turboprop, taking off from Cascavel to go to Sao Paulo. It belongs to the airline Voepass, an airline that no longer exists. Why? Because the accident in June will not only destroy the plane and those on board, but also the airline, which had in some way exhausted the patience of its customers. It should also be said that it had lost its protections because many of these companies operate on the margins of regulations, even when it comes to protections. We know they operate poorly, we've known it for a long time, but the day there's a disaster, the day there's a tragedy, it's very hard to find someone who will step up and defend that airline. That's why they shut down. So, as I was saying, the ATR, that ATR, if we're talking about the plane, it had a lot of problems. It had a lot of problems related to maintenance. For example, on the day it was going to take off, the pack one wasn't working. That means there was an issue. There are bleed air and air conditioning systems for the cabin, which are powered by the engines. Well, one of the systems wasn't working, which limited the altitude the plane could fly at to 17,000 feet, which is very bad because 17,000 feet that day was an area where there was severe icing. There was a SIGMET, a very clear weather message saying, be careful, there is very strong icing. It was reported as a danger to air navigation that day. So that's the altitude at which the flight will have to take place. Another problem. The other problem is that there was a de-icing system made up of what are basically rubber boots. They look like, you can see them from the outside. They're black surfaces you see on the front of the wings, on the leading edge of the wings. You can also see them on the tail, and actually they inflate and deflate. So this is how it works. At first they're deflated, right? It works in cycles. They're deflated, ice, so icing forms on them. Afterwards, compressed air comes in, so they are inflated. This breaks the ice. And then what happens next is that they will deflate again and allow the ice to form over and over. Those systems, which are absolutely essential in case of icing, were out of order. It wasn't documented. Why? Because it was observed the day before by a pilot, but it wasn't entered into the aircraft's maintenance log. Why? Because there are many airlines that work this way. They prefer to handle things verbally. That means if we write this down on paper or in a computer system, it's over. Why? Because at that point we trigger a whole chain of responsibilities. We're exposed to an audit, to an inspection. We have to work, if you will, within the framework of the regulations. We can't cheat. So what we usually do is we don't talk about it, we don't put it in the system, we keep it verbal. If you will, it's like I'm telling you that a company keeps a parallel set of accounts, an official accounting that's in the documents, in the bank account and everything, and then a hidden cash fund and a second set of books. That's exactly it. It's done, I wouldn't say everywhere, but it's done on every continent, including in Europe. I know a pilot who was fired 2 or 3 years ago from a European airline simply because one morning during a stopover, he discovered a large amount of oil under the plane. And then he copied it. The captain told him, no, whatever you do, don't put that in writing. It really has to stay between us. We'll keep it verbal. And then he didn't agree. Well, after a while, after 2 or 3 weeks, they stopped him from flying and then notified him of his dismissal. So you see, these are pretty common practices. Unfortunately, that's what I was saying. If the issue had been reported, the plane would have been allowed to leave anyway, but it would have left with it in Within the MEL or minimum equipment list, we would have acknowledged a failure in that system. So we would either change the route, change the altitude, or potentially cancel the flight, because we can't check all the boxes. But in this specific case, it was ignored. That means we say, well, there's this anti-icing or de-icing failure, forget about it. Turn a blind eye and operate the flight as usual. And so what we're going to do is take off. So there were 62 people on board at the time of takeoff. There was some hesitation at one point. Why? Because the numbers weren't tracked with the level of accuracy this kind of flight calls for. In particular, there was someone who was denied boarding. So that saved him. It saved his life. The airport was packed when he arrived. And so by the time he got to boarding, it was too late. They stopped him from getting on. So that's why there was a discrepancy at one point with the numbers that were reported at the time. But the total number is 62 people. So the aircraft takes off, climbs to flight level 170, and stays at that altitude for quite a while. What will happen next? Keep in mind the plane is under autopilot control. The pilots see the icing forming and comment on it. They say, yes, did you see there's icing, there's ice forming. Not only do they see it, but there's also the SIGMET, the weather message I mentioned, which says there's severe icing. So on the wings, the icing starts to form. The pilots, even though they know the anti-icing system is down, still try to use it from time to time. In reality, it seems that it was actually working fine on one side. It wasn't working on the other side, so there was an uneven buildup of ice. So I don't know, in the grand scheme of things, if it's better to have a plane that turns into a popsicle symmetrically, or if maybe it's worse if it only becomes a popsicle on one side. Well, that's an open question. In any case, the pilots are flying like that. And then suddenly they get alarms. So the alarms, they're performance alarms that they'll get in the TR, because in the past there have actually been incidents of icing, and that caused accidents. So on the TR, there's a system that monitors the aircraft's performance. It's not a system that knows if there's icing or not. That's not what it is. The system will monitor the aircraft's parameters and will check its speed, check the engine RPM, all of that, check the position of the flaps, and to say to itself, in this configuration, with this engine thrust, this torque, the torque applied to the shaft and propeller, what is the correct speed we should have afterwards? If he sees that the speed is abnormally low, or that the speed is degrading, that it is dropping, he will send an alert saying there is a problem. That's all there is to it, and the pilots have to investigate why. So in this specific case, they got those alerts again, telling them to be careful, there is a degradation in performance. Why? Because during this time, since the aircraft is controlled by the autopilot, well, in a way, the autopilot has had many cases like this. It hides the problem. It's going to hide what the plane is doing from you. I'll give you an example, maybe a bad one, but just so we're on the same page. Imagine driving a car with a steering arm problem that causes it to pull right. You notice you're constantly correcting with the wheel, which signals an issue. As it worsens, you need to correct even more. You feel like you're gripping the wheel hard to one side just to drive straight. You know there's a problem. Now imagine that the car has a pretty dumb autopilot that just wants to control the steering wheel to go straight. What is it going to do? It's going to hide the problem from you because it will feel that it's pulling to one side. So it will use more and more force on the steering wheel until it can't anymore. But at the moment it lets go. Well, the situation will be very, very serious, because you see it didn't. It hit it. It's exactly the same in an airplane. What it does is that the autopilot corrects until it reaches the point where its inputs no longer get a response. He feels that the plane is no longer responding to him. And what is he going to do? Those electronic circuits say, okay, just let go of everything now. And so it's going to send an alarm and disconnect itself. And the pilots suddenly find themselves with a plane that's behaving terribly. You see, that's the danger. When you let these situations fester anyway, they had to start their descent. The air traffic controller tells them, listen, wait a little bit, because he had some traffic, so he keeps them a bit longer, 2 or 3 more minutes at level 170. At some point he starts a right turn, so they begin a turn. And you need to know one thing. when you start a turn with a plane that's right at the edge of available lift, so it has lost speed. It has an aerodynamic profile that's distorted by ice. It's more nose up, increasing the angle of attack, so air strikes the wing undersides at a steeper angle, so it's barely flying. And if you take this plane and add a turn to it, at that point it's over. At that point it's going to stall then. The ATR type plane, then it has anti-stall protections. So not only does it have an alarm, but be careful, you shouldn't rely too much on the alarm because the alarm assumes there's no icing. Most of the time, the problem with icing is that you can have a situation where you get the alarm and the stall almost at the same time. Whereas when the wing is clean, you get the alarm and then much later you get the stall if you keep pushing it. The issue is that it's too close together if there's icing. Another thing it has a system that pushes on the control stick. That means it has a kind of small actuator that will push on the stick when it senses the approach of a stall. That means it will want to lower the nose of the plane to relieve the wings, to reduce the angle of attack, and that's what you need to do when a plane stalls. And you want to avoid going all the way into the stall, you have to push on the stick. So here the plane starts to do it by itself. And so we're going to be in an absolutely extraordinary situation here, but actually not that extraordinary, because as we've seen today, this channel, I don't know how many hundreds of videos there are on it. We've seen it in a lot of videos. Regular viewers know what I'm going to say. It's that at the moment when the stall alarm goes off, the stick pusher engages. What does one pilot do? We recall it wasn't recorded who did what. One pilot grabs the control stick and pulls. So imagine the following situation. You have a plane with ice-contaminated wings. It's very slow, high angle of attack, degraded performance, as the system itself says. It's banked. We're in a turn. There, suddenly, we have a stall warning and a stick pusher. And what does he do? He pulls on the stick. There isn't any. If I do that in a plane, I expect to die. There's no reason to do that if you don't want to die. Really, it's a deadly situation. But for some pilots who aren't very well trained, it's still mostly instinctive. Because when the plane stalls, what's the feeling? The feeling is your stomach jumping into your throat. It's like falling in a way. So the fall, how are we going to soften it? If instinctively I want to stop the fall, I pull back on the stick because I'm used to, when I pull back on the stick, the nose comes up. Except that in these cases, when it happens unexpectedly, it's better to develop the reflex that if your stomach rises, you push the stick forward. We have more chances in the balance of probabilities we'll get out of it much better than if we pull back. So he pulls back here, they go into a deep stall, the plane spins once. And even when we look at the situation charts provided by the investigators, we realize that the plane stalls. What does it do? Next, it climbs. So there's a little climb. So here he's pulling. We're going to trade energy, kinetic energy for potential energy. So we pull sharply, the plane goes up again. He can do it because we'll direct the velocity vector upward, causing us to lose speed again. So what are we going to do? We're going to enter a deep stall. And now it gets very serious. So it tilts at 90 degrees. And actually on these very unstable aircraft, you can even try it on flying club planes. When you reach certain points, you can grab the stick and pull it sharply toward you. And what we're going to do is, toward the horizon, do this right away. That means we're going to lose lateral control completely. And here's what will happen. So the plane rolls onto its side and then starts spinning. Then they try to recover it, but because at first it was turning to the right. So at first it goes into a spin, so it makes a turn to the right. Afterwards, the pilots try to correct it in a disorganized way. They manage to stop the spin to the right, but then they go into a spin to the left. And the back slides out. Damn shit. Holy shit. That means they go one way, they do 2 or 3 turns in one direction, and then they go the other way. So you need to know one thing. Once they're in a flat spin, as it was shown because people started filming. So it was daytime when they saw the plane coming out of the clouds, and people were impressed to see this aircraft spinning flat. On itself, it's a spin, a flat spin. Airliners like the ATR, but also others, like Airbus, the Airbuses, the Boeings, all of them are not certified. to go into a spin and be able to get out of it. It's not something that is analyzed, tested, or validated, any of that. So that means that potentially, I don't know about the ATR, but potentially because it's uncharted territory, it's an unknown area. Potentially, if they go into a spin, maybe there's no way to get out of it, you know. Potentially, we could be in a situation where physically there's really no way to get out of it. So, what he does is he goes into a flat spin and he starts spinning. So, he's spinning at a rate of 45 degrees per second. You see, it's actually pretty abrupt. So, it turns 90 degrees every 2 seconds. So, a full turn in 8 seconds. So he's going to fall for 68 seconds. It's going to last, the fall will last more than a minute. So people are stuck to their seats and they're just spinning, and the pilots can't do anything at all. So here the angle of attack that was measured is 70 degrees, but be careful, it's not really 70 degrees. The angle of attack sensor measures up to 70 degrees. So if it shows 70, it means it has reached its limit. In reality, the plane is falling like this and the air is coming from below, right? The angle of attack is probably 80 or 90 degrees at times. So the plane is falling flat while spinning around its own axis. So is there a way to recover it? As I told you, we're in a deep stall. The speed, the velocity vector is almost zero. The angle of attack is 90 degrees. How to recover it? It's a mystery, a complete mystery. It's not something that has been, as I told you, analyzed or tested or anything like that. Differential thrust, the rudder pedals, all that. But let's not kid ourselves. We'd have to put a plane in that situation. It's not simple. It's not easy to get out of it. I'm not saying it's impossible, but I'm saying it's not simple. All the more so because be careful, the wings are still contaminated with ice. That means this isn't a plane in a normal situation. It's a plane that's contaminated with ice. That means aerodynamically these wings aren't worth much. So there you go. The aircraft in this way crashes. It narrowly avoids houses. So here we don't have, maybe the only good news in this story is that there are no injuries on the ground. There isn't really any material damage on the ground either. The plane falls vertically and stays within its own footprint. It doesn't move an inch. It falls. The rescuers arrive. The hospitals in the area go on alert. And then we find out that, well, everyone is dead, right? All 62 people are dead. The investigation that starts, well, will reveal that the airline, Voepass, well, it's a disaster, right? They realized that there was poor maintenance, poor documentation, poor procedures. The plane itself, by the way, had hit something. It had hit the runway at some point just a few months before this accident. It had lost hydraulics, and then they landed. And they hit the tail, the back of the plane. They had a lot of problems like that, small ones and big ones, all covered up, swept under the rug. And the regulator who turns a blind eye. And at that time, in the weeks that followed, companies that had code share agreements with Voepass, that had arrangements with Voepass to honor each other's tickets or things like that, or to sell tickets under the same code or something like that, they began to distance themselves given the worsening situation and bad publicity. That's how all companies operate when there's negative press. What did they do? They withdrew their code, so they stopped working with Voepass, which went bankrupt right after. So it's a company that no longer exists. Historically, it was still founded back in 1995. Usually when we see this kind of dangerous companies, generally they show up, they break equipment within 18 months, 2 years, and then they shut down. This one had existed since 1995, just a single company. It didn't exist continuously. It's a project that dates back to 95. Sometimes it operated, sometimes it stopped, sometimes it operated, sometimes it stopped. Like many airlines, it was barely scraping by financially. But there you have it, 62 lives lost senselessly. They sent a plane into severe icing, which was known and announced, with a de-icing system that was out of order. And once we got into the situation and the performance was deteriorating and the plane was picking up ice and all that, well, we ignored the situation and kept going. I mean, my friends, there are people who are afraid of planes. Me, I'm afraid of pilots. I won't hide it from you sometimes. Not all of them, of course, but when you see things like this, you just wonder what is going on. What more could ATR, ATL, or the authorities have done so that this doesn't happen? I mean, at some point you think if you see the wall and you want to crash into it, no one can stop you. And by the way, the accident report invents a concept of willful blindness. They said they were willfully blind, whatever that means. I'm just telling you as it is. Thanks, my friends, for watching this video so far. And then I wanted to announce to you the release of my book Astrology, the sequel to the previous book. It's not a new edition, it's really the sequel. It's a bit bigger than the first, and as long as the plundering continues, I'll keep releasing these books because I see it as a duty. You can find it on Amazon in paperback format, and soon the first one will also be available in digital format. See you very soon, and I'll see you in the next video.